Hi guys, you've been working really hard on topic 13, learning about fractions. Today we're going to do a study guide on Google Form, and I just wanted to show you what I mean when I say you can draw a model for just a few of these problems. So I'm going to just model those out, and hopefully you can see them on my notebook paper. So the first one I wanted to go over with you is the first story problem. It says 3 friends work on a project. Cindy does 4/8 of the project. Kim does 3/8 of the project. Sandy does 1/8 of the project. How much of the project do they complete all together? So first of all, you want to think about your important information. They're all working on one project, so the project is the whole in this story problem. I know that Cindy completes 4/8, and I know that Kim completes 3/8 and Sandy completes 1/8. Something that I notice in this problem is that all of those 3 fractions have the same denominator. They all have an 8 as a denominator. So the first thing I did was model out a number line, a whole that shows 0 to 1, and then I plotted where 4/8 would be for Cindy, and I put a C there, where 3/8 would be for Kim, and I put a K, and where 1/8 would be for Sandy, and that would be the S. Then I thought about this problem, and I thought, well, even though I've plotted this information, it really doesn't tell me if how much they've completed altogether. So I decided to model it out another way. I again drew a number line and went from 0 to 1. That was the whole project. So the 0 to 1 represents one whole. I still partitioned it into 8 because my denominator was an 8. So there are 8 equal parts between the 0 and 1. Then I made a jump, and you can see Cindy's jump that it goes all the way to 4/8. And then I counted on from 4/8. I added 3 more 8s, so 3 more jumps for Kim, and then 1 more jump, which represents Sandy's 1/8 jump. So when I did all 3 of those jumps on my number line, I made it all the way to the 1. So that means together they all completed the whole project, or 8/8 of the project was completed. So that's just an example of how you can model this out on scratch paper. Okay, it's really important that you listen to the whole story problem and you understand the important parts and that you're able to model it out either with a number line or fraction strips like I'm going to show you in just a second. So I'm going to scroll down to another problem, and this one is about Jill and Owen. It says, Jill finished reading 2/3 of a book for a summer reading project. Owen read 2/8 of the same book. Who read more of the book? And my hint was that you could use a number line like we did for the first problem to model it out and check, or that you could do a fraction strip model. So for this example, I did fraction strips to model it out. Okay, hopefully you can see my notebook again. I modeled out 2 wholes so that they were the same size. It's really important when you're making these models that your wholes are equal. For Jill, since she did 2/3, I see that her denominator is a 3. So I knew that there should be 3 equal parts. And since the numerator was a 2, I colored in 2 of those parts. For Owen, I represented what he read with 8 parts because the denominator was an 8, and I only shaded in 2. What I noticed about these 2 fractions is that they have the same numerator. They both have a 2 as the numerator. The part that is different is the denominator. I know that the bigger the number for the denominator on the bottom, the smaller each part will be. So I proved that with my picture model that I can see that 2/3 is greater than 2/8, which means that Jill read more. Okay, so that's how you can model with fraction strips. I wanted to give you another example, and this one is not comparing fractions, but finding equivalent fractions. Remember, we know that equivalent sounds like equal, and that's what equivalent means. It means that they are equal fractions. So we're going to go scroll on down to where we talk about, I can find it really quickly. This question here about George. It says, George wants to know if 2 pieces of wire are the same length. So he's wanting to know if they are equivalent. It says one wire is 6/8 of a foot. The other is 3/4 of a foot. Are they the same length? And my hint is to draw two number lines to compare the fractions on scratch paper. So this is how I did that. Okay, I've modeled it out for you. You can see that my fraction number lines are equal. I made my zeros line up and I made my one whole line up. So they each represent the wire. Now I did my first number line partitioned into 4 equal parts because I wanted to model out 3/4, and 4 is my denominator. The second number line, I did eighths, so there are 8 equal parts because 8 is my denominator and 6/8. When I look at that, okay, I could ninja chop it. Hard to do on camera, and they would be at the same point. So that's why I drew a box around them. So that shows me that 3/4 and 6/8 are equivalent fractions. Another way that you can check that is by multiplication. If you can multiply the numerator and the denominator by the same number, then you have an equivalent fraction. So 3 times 2 is 6, and 4 times 2 is 8. So that is another way of proving to myself and checking my work that 3/4 is an equivalent fraction with 6/8. So when I look at that problem, then I can say that, yes, they are the same length because 6/8 is equal to 3/4. Okay? We're going to scroll down. I have one more example for you. Sometimes boys and girls have a hard time with looking at fractions that are equivalent to whole numbers. And what I want you to think about when you're looking at fractions as whole numbers is you can think of that fraction bar, okay, as 8 divided by 4. Okay, and when I think of that, I know that 8 divided by 4 is 2, so 8/4 is the same as 2 wholes. And this is what it looks like as a picture model. If I draw 2 wholes and I partition them into 4, since my denominator was a 4, so that each one of those has 4 parts, then I have 1, 2, 3, 4, 5, 6, 7, 8 parts, or 8/4, and that also equals 2 whole squares in that picture. Another example is when 1 is my denominator, like we see here. So if I have 3/1, again, we can think of that fraction bar as a division sign. 3 divided by 1 equals 3, or it could look like this picture model right here. They're not partitioned into any parts because 1 is my denominator and I have 3 wholes. Okay, so hopefully this will be a good sample for you of how you can model these out to solve. I don't expect you to know the answer without working them out on scratch paper. I do encourage you to get that. If you have any questions, feel free to ask your teacher and we will do our best to help you. Okay, have a wonderful time.